Space physics begins with understanding gravity, the force that keeps planets in orbit around the sun and moons around planets. In space, gravity follows Newton's law of universal gravitation, where the force depends on the masses of objects and the distance between them. Two objects with mass attract each other with a force that gets stronger when masses increase and weaker when distance increases. The inverse square relationship is crucial. When the distance doubles, the gravitational force becomes 4 times weaker. For IGCSE students, it's important to understand that orbits occur because objects like satellites have enough sideways velocity to balance the inward pull of gravity. This creates a continuous falling motion around the central body. The satellite is constantly falling toward Earth, but moving forward fast enough that it never hits the ground. The International Space Station is a perfect example of an object in orbit. The International Space Station is constantly falling toward Earth, but moving forward fast enough that it never hits the ground. This is what we call an orbit. Different orbital heights result in different orbital periods. Objects closer to Earth orbit faster than those farther away. This is because gravity is stronger closer to Earth, pulling the satellite around its orbit at a higher speed. In summary, orbits are all about the perfect balance between an object's forward velocity and the gravitational pull of the body it's orbiting. This understanding of gravity and orbits forms the foundation for exploring our solar system further. Our solar system consists of the Sun at its center, with 8 planets orbiting around it. The Sun sits at the center, with the 8 planets orbiting around it in different paths. The solar system is divided into inner planets, which are rocky and relatively small, and outer gas giants, which are much larger. The inner planets consist of Mercury, Venus, Earth, and Mars. These 4 planets are relatively small and have solid, rocky surfaces. Mercury is the smallest and closest to the Sun. Venus has a thick atmosphere. Earth is the only known planet with life. Mars has a distinctive red surface. Beyond Mars lie the outer planets, Jupiter, Saturn, Uranus, and Neptune. These planets are much larger than the inner planets and are primarily composed of gases like hydrogen and helium. Jupiter is the largest planet with a distinctive red spot. Saturn has its famous rings, Uranus rotates on its side, and Neptune has strong winds and a deep blue color. Between Mars and Jupiter lies the asteroid belt, containing thousands of rocky bodies. The asteroid belt contains numerous rocky bodies of various sizes. Beyond Neptune is the Kuiper belt, home to dwarf planets like Pluto and many icy objects. Pluto was once considered the 9th planet, but was reclassified as a dwarf planet in 2006, as it shares its orbit with many similar objects. Earth is uniquely positioned in what scientists call the habitable zone. This is the region around a star where conditions might allow liquid water to exist on the surface of a planet. It's often called the Goldilocks zone. Not too hot, not too cold, but just right for liquid water, which is essential for life as we know it. Earth is perfectly positioned in this zone, allowing water to exist in solid, liquid, and gas forms. Combined with its protective atmosphere, this makes Earth the only known planet capable of supporting life. At the center of our solar system is the Sun, a medium-sized star. The Sun contains over 99% of all mass in our solar system. It's incredibly massive, with a diameter 109 times that of Earth. Its surface temperature is around 50,500 degrees Celsius, while its core reaches 15 million degrees. The Sun's incredible energy comes from nuclear fusion in its core, where hydrogen atoms combine to form helium, releasing massive amounts of energy in the process. This energy is crucial for life on Earth, powering photosynthesis in plants and driving our climate and weather patterns. We now explore space exploration and technology, which has evolved dramatically since the first satellite launch. Space exploration began with Sputnik in 1957, followed by major milestones like the moon landing in 1969, the Space Shuttle program, and more recent Mars rover missions. To leave Earth, rockets must achieve escape velocity, about 11.2 kilometers per second. This is the speed needed to break free from Earth's gravitational pull. Space missions include satellites for communications and GPS, space probes like Voyager that explore distant planets, and rovers like Curiosity that study Mars. Space exploration faces significant challenges: radiation exposure that requires shielding, microgravity that affects human physiology, and vast distances that create communication delays. Rocket propulsion works on Newton's third law. For every action, there's an equal and opposite reaction. As gases push out of the rocket moves in the opposite direction. Space technology has many practical applications in our everyday lives, including GPS navigation, weather forecasting, global communications, and scientific research. Future space missions aim to return humans to the moon through the Artemis program and eventually send the first human expeditions to Mars in the 2030s. The future of space exploration will expand human presence beyond Earth, develop new technologies that benefit everyday life, solve challenges of long-duration space travel, and foster international collaboration. As we continue to explore space, we'll expand our understanding of the universe and develop technologies that benefit life on Earth.